Welcome to Labracazam, where we make science make sense.
So you're saying there's no sound in space at all? There's like not a single alien dance party going on out there?
None that I've been invited to, but today we're gonna test that theory.
How? Are we sending Bert into space?
Oh, sure, send the robot.
Don't worry, nobody has to leave the planet. To understand if there's sound in space, we have to learn about the properties of waves. Waves are regular patterns of motion that transfer energy from place to place without transferring matter, like this. As you can see, the people only move up and down. They don't actually travel from the beginning of the wave to the end of it. Here, let's break it down. This is a wave tank. Hit it.
Looks like the waves are just moving from one side of the tank to the other.
Interesting observation, Izzy. What do you guys think would happen if I take this ball and put it into the wave tank?
I think that it'll move with the wave from one side of the tank to the other.
I think it'll just bob up and down.
Let's find out.
Nailed it.
It's moving up and down, but not in the direction that the wave is moving.
Exactly. Matter doesn't move through waves, only energy does. We can understand more about waves by adjusting the settings on our wave generator.
Looks like the adjustment is making the waves get closer together.
Right. The distance between wave peaks is called wavelength. The shorter the wavelength, the more energy a wave has.
What if I change the knob labeled amplitude?
What do you notice?
That adjustment made the wave smaller.
Right. Amplitude is how tall or short a wave is.
Can you measure amplitude and wavelength?
Yep, scientists do it all the time. The amplitude is the distance from the wave's peak to its resting point, which is the level of calm water. The wavelength is the distance from peak to peak.
Is this the same amplitude and wavelength that they use for music?
It is, which brings us to our next topic, sound waves.